This is the practical schedule of rapid application development course, and I'm using this website to teach. Then using two videos, actually I have completely discussed this particular section, and these three sections I have asked you to complete as a homework. Okay, so and using three videos I have completely discussed this particular section, and in this video I am going to discuss this section. Okay, now let's go to our website. There, this one I have completely discussed using videos, and this section, this one, and this one, these three sections I have asked you to complete them as a homework, and this particular section I have completely discussed using videos, and in this particular video I am going to discuss debugging your applications. Now let's go to this section, debugging your C# apps. Debugging refers to the process of trying to track down errors in your programs. Okay, debugging actually means tracking down errors in your program. It can also refers to handling potential errors that may occur. There are three types of errors that we'll take a look at. These are the three types of errors. Design time errors are there, then runtime errors are there, and also there are logical errors. The longer your code gets, the harder is to track down why things are not working. Okay, so when you are writing longer codes, then it's very difficult to track the errors manually. Okay, by the end of this section you should have a good idea of where to start looking for problems, but bear in mind that debugging can be an art itself, and it gets easier with practice. Okay, errors at design time. Design time errors are ones that you make before the program even runs. Okay, design time errors means before you run the program, you can actually track these errors. The program won't run at all most of the time. Okay, if you have design time errors in your program, most of the time your program will not run. Okay, you will get a pop-up message telling you that there were build errors and asking would you like to continue. Okay, you will be asked a message like that. Later you will see that design time errors are easy enough to spot because the C# software will underline them with a wavy colored line. Okay, when you have errors, I think we have already seen this. Using a wavy colored line, these errors are underlined. You will see three different colored lines: blue, red, and green. Okay, these wavy lines, something like this. Okay, here it's red color, and likewise blue, red, and green, there are three colors by default. You can see the blue wavy line is lines are known as edit and continue issues, meaning that you can make change to your code without having to stop the program altogether. Okay, without stopping your program, these errors can be fixed. Okay, red wavy lines are syntax errors. Now if you have red wavy lines, okay, they are syntax errors such as missing a semicolon. If you miss a semicolon at the end of a line of code, then you will see a small segment of red wavy line. Okay, you will see that, such as missing semicolon at the end of a line or missing curly bracket in an if statement. Okay, if we have included the opening bracket but we have forgotten to include closing bracket, then in that case it will be shown as a red wavy line segment. Green wavy lines are compiler warnings. I think we have already encountered these different lines. If you have green wavy lines, that means they are compiler warnings. You get these when C# spots something that could potentially cause a problem, such as declaring a variable that's never used. That means if you have declared a variable and in your program you have not yet used it, in that situation that is shown by a green wavy line, because if you are not using a particular variable, you do not have to declare it. It is a waste of our memory. Okay, that is why such a compiler warning is shown. Then let's look at red wavy lines. Okay, so before that let's start Visual Studio IDE. Create a new project. Let's start a forms application. Let's name this as errors 1. Okay, likewise let's save it in the same location. Now if you click this, okay, then you create we create our project. Now let's see, in the image below you can see that there is a red wavy line under text box 2. Earlier versions of Visual Studio may have blue wavy lines instead of red ones. Okay, that means if you use an earlier version of Visual Studio IDE, you will see this red wavy line as a blue wavy line. Anyway, let's put yes, in order to explain this, let's put a button first and then a text box. Okay, now by default if you select the text box, now if you look at the name, it is our text box 1. Okay, now if you double click on the button and now we are going to program the button, there we type text box 2.text. we try to assign some text. Okay, now what is the problem here? Here I have written it as text box 2, but in our program, if you look at this text box, okay, Okay. Text box 1. The name property. The name of this text box is text box 1, and also you cannot see a text box with name text box 2. Okay, therefore this is an error. We do not have such a text box called text box 2. Therefore that error is shown by a red wavy line. Now if you get your mouse pointer there, the name text box 2 does not exist in the current context. Okay, likewise you can see the error. Then from here you can see the potential fixes. Okay, likewise potential fixes you can see. Anyway, that is how an error is displayed by the IDE, and this kind of displays are really helpful when you write longer programming codes. This is and also the other thing is, in earlier versions you will see this red wavy line as a blue wavy line. Okay, anyway, but this is how this is the latest version. Okay, to this particular date, this is the latest version of the IDE. Okay, I am using, and now this is an edit and continue error. It's been flagged because the form doesn't have a control called text box 2. It's called text box 1. We can simply delete the 2 and replace it with the 1. The program can then run successfully. Holding your mouse over the wavy underline gives an explanation of the error. Okay. Then click the arrow next to the light bulb to see a list of potential fixes. Okay, then here you can see the list of potential fixes. Okay, one solution: change text box 2 to text box 1. Okay, now you can see error disappeared. Okay, likewise you can work with this. Some of these explanations are not terribly helpful, however. Okay, so anyway, now red marks, let's look at these are syntax errors. Syntax is the grammar of programming language. All those curly brackets and semicolons, think of a syntax error as the equivalent programming spelling mistake. Okay, so something like that. In English you make spelling mistakes. When you do programming, syntax errors are something like making spelling errors. For an example, if you have missed a semicolon at the end of a line of code, that is a syntax error. If you have missed a curly bracket of your if statement, that is a syntax error. Okay, therefore now let's see. Now once you write, if you miss the semicolon there, you will see a red wavy line segment, and if you get the mouse pointer there, represents text as a sequence of okay, anyway, now it shows us the error semicolon expected. Okay, now when you put the semicolon, error, that red wavy line disappears. Okay, holding the mouse pointer over the red wavy lines, the following message, okay, semicolon expected, it's telling us that a semicolon is expected where the red wavy underline is. In the next image, we missed out a round bracket for the if statement. Okay, so now if you write something like if, let's say let's declare an integer, okay, int x, okay, int x integer variable, then let's say 56. Okay, now here you can see a wavy line segment, okay, in a different color, it's not red. Anyway, it says that the variable x is assigned but its value is never used. It's that kind of situations. So we have declared the variable but we have not yet used it, therefore it is shown as an error. Okay, and if here, let's say if greater than 3, then here I display message box dot show hello. Oh, hello. Okay, so now there is no any error. Okay, now there is no any error, but if you miss this by a mistake, you have missed this, then what happens? Now a red wavy line will appear, and if you get our mouse pointer there, it says closing parenthesis is expected. Okay, likewise these errors can be seen if you miss this. Now here you can see closing brace is expected. That means it consider this one as the closing brace of this one. Okay, if you I deleted this brace, closing brace, but this one it considers as this one, then this one it considers as this one, and finally for this there is no such brace. That is why here it says closing brace is expected. Okay, so once you have put this, error will disappear. Okay, then let's talk about green wavy lines. These are compiler warnings. These are called compiler warnings. The C# way of alerting you to potential problems. As an example, here is some code that has a green wavy underline. So now let's see. A string let's say compiler, any variable name, okay, warning. Now here you will see a green wavy line below this variable. When get the mouse pointer there, when the variable compiler warning is declared but never used. If you have declared the variable but we have not used it in our program, then such kind of a declaration is a waste of memory. That's why compiler gives us a warning. Okay, once we use it for some purpose, for an example, now let's say compiler warnings to this one, we put some value. Okay, now you can see that yes, anyway, again message box dot show Now you can see this green wavy line has disappeared because we have used that variable for a particular purpose in our program. Okay. Holding the mouse pointer over the green underlines gives the following message. Okay. The same message we could see. C# is flagging this because we have set aside some memory for the variable, but we are not doing anything with it. That is a waste of memory. Okay. This one is easy enough to solve, but some compile errors can be a bit a nuisance, and the message is not nearly as helpful as the one above. Okay, so this kind of ones are simple, but there are complicated compile errors as well. You will encounter such kind of complicated errors in future. Okay, in near future. Whatever the color of the underline, though, the point to bear in mind is that this C# thinks it has spotted an error in your code. It's up to you to correct it. Okay. Okay, then green color wavy underlines. So what should you feel about them? So C# simply spotted an error. Okay, C# thinks that whatever the color of the underline, then what you should understand is C# has detected an error, so then you can correct it. Okay. In the next part, we look at runtime errors. Okay, now we have discussed design time errors. Okay, so now let's look at runtime errors. Runtime errors in C#.NET. Runtime errors are ones that crash your program. Okay, if you did not handle a runtime error successfully, then definitely your program would crash. Okay, so the program itself generally starts up okay. In runtime errors, you do not see the error. Okay, your program will start up without any problem. Okay, then it's when you try to do something that error surfaces. A common runtime error is trying to divide by 0. In the code below, we are trying to do just that. Okay, now let's see you will understand the meaning of this paragraph. Okay, you do not usually your program initially starts up without any problem, but once you try to do something, then that error comes. Okay, so then let's see integer variable num1 we assign 10. No problem with this line of code. Okay, no errors are shown. Int num, actually compile error is shown. That's just because we have not yet used the variable. Later we when we use that wavy line will disappear. And here 0, no problem. Only the thing is green wavy lines are shown. Okay, green wavy lines are shown. Okay, so that is the only problem. Other than that, no errors. Our answer okay. Now once you have seen the answer, let's try to display it in a message box. Okay, this is our code. Okay, and the other thing is here another error is shown. Answer, if you get the mouse pointer there, you will see cannot convert into a string. That means answer is an integer variable, but in this method, show method, it requires an string. Okay, therefore you have to convert it to an string using this method. Okay, using this method you have to convert it to a string. Okay, now this code, no error is shown. Okay, no error is shown, but let's see what happens when we try to run this code. That means program starts up without a problem. Okay, program starts up without a problem, but when we try to click the button, okay, it shows us an error. Attempted to divide by 0. That means that is the error here. So this line is was executed without any problem. A variable called num1 was created and value 10 was assigned. Then a variable called num2 was created and value 0 was assigned. No problem. Another variable was created and it's called answer, and by default 0 is assigned in that situation. But when we try to execute this line of code, num1 is 10 now, num2 is 0. Then the answer, what is the answer? If we divide a particular number by 0, that is an indeterminate form. There is no such answer for that calculation. Okay, you cannot divide by 0. Therefore this causes an error and it's shown like this: attempted to divide by 0. Okay, attempted to divide by 0. This kind of errors are called runtime errors, because your program starts up without any problem, but when you try to do something, this kind of errors will occur. Okay, the program itself reports no problems when it is started up, and there are no colored wavy lines. When we click the button, however, we get the following error message: had we left this in a real program, it would just crash altogether, bug out. But if you see any error message like this one, it's usually a runtime error. Okay, so if we keep this error unattended and you just created your application, then definitely when the users are trying to perform this kind of calculation, for an example division by 0, then it will crash your application. So that is not a good thing. You have to be careful in this kind of situations. Okay, had we left this in a real program, it would just crash altogether. But if you see any error message like this one, it's usually runtime error. Look out for these type of error messages. It does take a bit of experience to work out what they mean, but some, like the one above, are quite straightforward. You will see how to handle errors like this soon, but there is one final error type you have to know about: logic errors. Okay, so how to handle runtime errors? Here I have just shown that this computation can cause a runtime error. Then how can you handle that? That will be discussed later. Before that, let's try to understand the third type of errors. Now we discussed design time errors, then we discuss runtime errors. Now the third type is logic errors. Logic errors are once where you don't get the result you were expecting, you won't see any colored wavy lines, and the program generally won't bug out on you. In other words, you made an error in your program logic. As an example, take a look at the following code. That means you have not made any design time errors, and also your program is running properly just because you have not made any runtime errors, but still there can be an error in your program. Those type of errors are called logical errors. Logical errors, that means without any problem your program runs, but the output of your program does not give you what you expect. Okay, as an example, take a look at the following code, which is attempting to add the numbers 1 to 10. Here start loop 11, int end loop 1 with 2 variables, answer 0. For I, we start with 11, then we check the condition I less than end loop. Okay, anyway, let's try this code. Let's try writing this particular code. Okay, let's try writing this particular code. Okay, now you can see green wavy lines just because we have not used these 3 variables in our program. Okay, now we have for loop I start loop sorry, so here int I, end loop we increment, then yes, okay. Now you do not see any errors. Then what was the purpose? Add up the numbers 1 to 10. Okay, so what happens here? We start from 11, end with 1. So let's see the output. Output is the answer is 0. That means this is not the expected answer. This is not the the summation of numbers from 1 to 10. Okay, so now here we have a problem in the logic. No, here we start with 11 and 11, then we check the condition whether 11 is less than 1. 11 is less than 1. Okay, then the logic is wrong, but still you do not have any design time errors, as well as you do not have any runtime errors. Okay, that this kind of errors we call them as logic errors. Okay, when the code is run, however, it gives an answer of 0. The program runs okay. You didn't produce any error message or wavy lines. It's just not the correct answer. The problem is that we made an error in our logic. The startup variable should be 1 and the end loop variable 11. Okay, then actually start loop, this one should be 1 actually, in order to do our purpose 1, then this should be 11, then it starts with 1, then up to the variable less than 11, that means up to 10 it will work. Then let's see, now the answer is correct. Okay, so in that way logic errors means you do not see any design time errors, you do not encounter runtime errors, but still your program is not giving the expected output. Okay, the problem is that we made an error in our logic. The start loop variable should be 1 and the end loop variable 11. We got it the other way around in the code, so the loop never executes. Logic errors can be very difficult to track down. Then you feel actually these errors are extremely difficult to track down. To help you find where the problem is, C# has some very useful tools you can use. To demonstrate these tools, here is a new programming problem. We are trying to write a program that counts how many times the letter G appears in the word debugging. Okay, now when we have a logic error in our program, now if you have a design time error, using wavy lines you can detect. If you have a runtime error, that can also be detected. Okay, but logic errors are extremely difficult to detect. Therefore, in Visual Studio IDE there are certain tools. So in order to teach these tools, we are trying to write a program that counts how many times the letter G appears in the word debug. Once not only debugging, once a word is given, once a particular word is given, how many times a particular character appears in that word. Okay, that is our problem. Then we are going to write a program to solve that problem. Start a new C# application. And anyway, let's close this, close our solution. Then again we create a project, forms application. Let's name this as errors 2, and the same folder we will be using. Okay, and we create our project. Then we add a button to our form. Double click on the button, and now in the button we are going to write the code int letter count is initially 0. Okay, letter count is initially 0. Letter count variable. Okay, this variable stores the number of letters. Okay, a string str text debugging. Okay, this is our string. Zero, then int I, we assign it to 0, I less than str text dot length. Actually the meaning of that one is the number of characters. This will return number of characters in our string. Okay, this will return. Anyway, now I plus plus. So now here letter, so I have forgotten to declare another variable string letter. Letter str text dot substring one comma one. Now here in our substring method there are different ways. We can put start index only. The second way is start index and the length. Okay, start index is 1, length is 1 character. 1 means 1 character. Okay, now this explains. If you look at this, retrieves a substring from this instance. This substring starts at a specified character position and has a specified length. Returns. Okay, like that. Now if letter is G, then what we do is letter count, we increment the letter count. Okay, sorry, here as a string, this should be a string. Okay, because letter is a string, string is G. Now let's see. Now let's run this code and see the output. sorry, I have not included uh, okay, then we have to include a text box as well. To text box 1, text box 1 dot 1 dot text property, then we includes G appears, the character G appears, then here we put the letter count. Okay, that means letter count variable should store the number of G character in our string, this one. Okay, now let's see. It says 0 times. G appears 0 times. Okay, so that is an error. Now actually G appears 3 times. Therefore we have not got the expected output and no errors occurred. We could not see any design time errors. We did not encounter any runtime errors, but still we do not get the expected output. So there is a logic error. There is a logic error. Now how to track this? Okay, it's difficult, no? So so we are going to discuss certain techniques that can be used to track this kind of logic errors. Okay. The answer should of course be 3. Our program insists, however, that the answer is 0. It's telling us that there aren't and G's in debugging, so we have made a logic error. But where? Then where we have made the logic error? How to find that? Okay. C#.NET has some tools to help you track down errors. The first one we'll look at is called the breakpoint. Okay, now let's move to the breakpoint. Breakpoints, okay. Breakpoints in C#.NET. The first debugging tool we'll look at is the breakpoint. This is where you tell C# to halt your code so that you can examine what is in your variables. They are easy enough to add. To add a breakpoint, all you need to do is to click in the margins to the left of a line of code. Okay. For the time being, let's put a Okay. Anyway, let's now here, if you double click, a breakpoint will be added. Okay, breakpoint. Let's you will I will tell you what is a breakpoint. Okay, now we have added a breakpoint to line number 23, and now let's see. In the image above, we clicked in the margins just to the left line of 21. Okay, in our example code it's 23. Okay, don't worry about the line number. Okay, a reddish circle appears. Notice too that the code on the line itself gets highlighted. So here you can see reddish ball has appeared, and also the line of code has been highlighted. Okay, now to see what a breakpoint does, run your program and then click your button. C# will display your code. Now let's run. Then we click the button. Okay, then only it comes to the code inside these braces. Okay, so let's click the button, and now you can see now what you see. Okay, then there will be a yellow arrow on top of your red circle. Now you can see here now on top of our red circle you can see a yellow arrow. Okay, and the line of code will now be highlighted in yellow. Now line of code that is highlighted in yellow in this situation. No, if you want to enable line numbers in your code, click tools options from the C# menu at the top. On the options box, click the arrow symbol next to text editor, then click C#, click on general. On the right hand side, check the box for line numbers under the settings heading. Okay, likewise so this you should follow this one in order to, if your IDE does not display line numbers like this. Okay, line numbers are here. If your IDE does not display them, you can simply follow these guidelines and get the line numbers. Okay, you have to go to tools options and blah blah blah. It's simple, so I'm not going to discuss that one. Okay, press F10 on your keyboard, and the yellow arrow will jump down one line. Keep pressing F10 until line 28 in your code is highlighted in yellow. Okay, 28 here. Yes, this one. Okay, actually 28 means here it should be 30. Okay, it should be 30. Anyway, now here I now use F10 in the keyboard. I press it. Yes, F10. I press it one time. Then let's see. Okay. Okay. When okay, then Okay, it seems like F10 is not working in this version of Visual Studio. Okay, that kind of differences can be there. Okay, so anyway, you do not have to worry. Uh, you can do the same thing if you move to here. These function keys are shown within parentheses, but I don't know, in this situation F10 is not working. No problem. Anyway, let's use this button instead. Step over. So if you click yes until this line, it says okay. Now we have come to this line of code. Okay, then move your mouse pointer over the letter variable and C# will show you what is currently in this variable. Currently, yes, now we can get the mouse point there, letter E. Currently, letter in this letter variable we have E. Okay, now in that way we can see. Now using a breakpoint, actually we can check check the values during the execution of our program, the values of the variables we can check at now here we have a for loop. Even in a for loop we can check the values the variables get at each iteration. Okay, now here letter E. Okay, now hold your mouse over str text to see what's in this variable. Debugging. Okay, here also you can see debugging. Okay, although we haven't although we haven't yet mentioned anything about the substring method, what it does is to grab characters from text. Okay, substring, that is a method that can be used to grab a substring from a particular string. Actually, the meaning of substring method. Okay, the first one in between the round brackets means start at letter 1 in the text. The second one means grab one character. Okay, number of characters in our substring we specify. Here the first one says the index. First one says the index, where to start from our string. Okay, and if you look at our string, index means 0 1 2 3 4 5 6 7 8. 0 1 2 3 4 5 6 7 8. 8. Okay, likewise 9 characters. Here we have indices. Okay, now here we have to specify the index, and from beginning from that index how many characters we get. Okay, you have to specify as the second value. Grab one character starting at letter 1 and grabbing one from the word debugging will get you the letter D. At least that's what we hoped would happen. Okay, for the first time actually If it is 1 comma 1, then here it has grabbed E. Actually what we expected was the first character. First time we check the first character in our first run of our inside the for loop. In first run of the block we expected to detect D. Then we first time we to the letter we expected to get D. Then for the second time E, then B, then U, then G, then G, then I, then N, then G. Likewise, actually we wanted to move through the characters, but here at the first time we have got E. Okay, that's the problem. Now in that way we have found some problem has occurred. Okay, unfortunately it's grabbing letter E and not the letter D. The problem is that the substring method starts counting from 0, not 1. Okay, actually now hold yes, now here by a mistake we have thought that substring method starts from 1, but actually it starts from 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, therefore here now you can identify that here it should be 0. Okay, halt your program and return to the code. Change your substring line to this. Now if we want to do any modification, now here you cannot do it because we are debugging our application. Therefore you can go back to your code. Okay, then after that here you can put 0 here. Understood? For the time being you just put 0. Now you can say from the start from 0 index, one character is taken to our letter variable, it is D. Okay, now let's see. So type 0 as the first number of a string instead of 1. Now run your code again. Okay, now we save our work, we run our code again. We click this. This time the correct letter is in the variable. Halt your program again, click the breakpoint and it will disappear. Run the program once more and it will run as it should without breaking. Okay, now again let's see this. Now here we have, yes, we move. This is how execution happens. Okay, so it comes to this, the highlighted line, then to this. Again we move, yes. Now D has come at the first run of the block of our for loop. Now first character is D. Now that is correct. Okay, so anyway that part is correct. Now again let's remove the breakpoint. That is how you remove. You again click on the breakpoint, it will be removed. Then again we run our code. Still you do not see the correct output 0 times, but actually it should be 3 times. Again there is a logic error. Now how can you track it down? So have we solved the problem? Is the program counting the letter G's correctly? No, the letter count is still 0. So where is the error? To help you track it down, there is another tool you can use, the locals window. Another window is there. That window is called the locals window. Let's look at that. The locals window in C#.NET. The locals window keeps track of what is in local variables you set up in the chunks of code and not outside it. Add a new breakpoint. This time in the margins to the left of your if statement, then if statement, then here I'm going to add a breakpoint. Okay, here I'm going to add a breakpoint. Now run your program again and click the button. Okay, when you see the yellow highlighted line, click the debug menu at the at the top of C#. From the debug menu, click Windows Locals. Debug menu, Windows Locals. Then Locals window appears. This is our Locals window. You should see the following window appear at the bottom of your screen. Okay, this is what you could see. Keep pressing F10 and the values will change. Here is what is inside of the variables after a few spins round the loop. Now we say here values of each variables at this moment, because we are here now. Our breakpoint is here. We are here now. Therefore, letter D. Here we have D. Okay, we have executed this line, this line, this line. Then we have come to the for loop. Okay, then after that. Okay, after that, at the first run of the block, we have letter G. Okay, when actually program now when we click the button, then listen carefully. When we click the button, then it comes to this line of code and it will be executed. Then this one, then this one, then it comes to this line, then this one will be executed, then this one will be executed, and we have at a breakpoint only this line will be executed, and now we have halt our program. Okay, we have stopped running our program, we have suspended running our program. Okay, so now here locals window shows, if you look at letter, it is D. Now here D, because this substring have derived D 0 1. 0th index is D, 1 character, that is D. Okay, then if you look at I, it is 0, because initially this we have set I into 0 and then we have come inside the for loop. Okay, letter D, str text is debugging, letter count is 0. Okay, letter count that we have initialized it to 0. Okay, likewise you can see the values. Okay, now keep pressing F10 and the values will change. Here is what is inside the variables after a few spins round the loop. Okay, now you can see, now use this one, and then after that that line of code was executed. Now you can see no change happened for the variables, because then again to the next one. okay, because since this condition letter if condition was false, again it came to the for loop and now it's going to increment the value of I. Still it has not yet been incremented. It is shown in yellow color. If you look at the value of I in locals window, okay, locals window, you will see it as 0. This line, this incrementation has not yet occurred. Okay, when I click this, now you can see I value became 1. Okay, I value became 1. Then it checks 1 less than the length is 1 2 3 4 5 6 7 8 9, I less than 9. If you yes I less than 9, therefore it comes inside the block. Okay, then next line, still this line of code has not executed. Okay, so letter character is still D. Once it is executed, now you can see letter character is still D. Okay, now we can detect there is a problem. Actually our expectation was to come to E, still it is D, but our expectation was to move to E. Then there has occurred the problem. Now we can realize. Okay, in that way we can successfully use breakpoints to track errors. Okay, now let's move again. It comes here because the condition was false, so it came here, and after that it moves again to here. It comes then again it increments to 2, then check the condition, then it comes here. Okay, still letter is D, condition is false, no, therefore it comes here again to here. Likewise I will show you. Okay, D 5, then value of I is became 6. Still we can see in the letter character it is D. Okay, therefore some error has occurred. I is 7, now it became 8. Now I become 9, so we came to this line of code because I became 9. Now the condition was false, therefore the compiler comes to this line of code. Then after that we come to this line of code, and then after Okay, now we have finished. Okay, now what you could see, now always we got D in letter. Now you can understand something got wrong. Okay, therefore the variable I now 3 is the variable I is now 3, letter is still D, and letter count is still 0. Keep pressing F10 and go round the loop a few times. What do you notice? Keep your eye on what changes in your locals window. The changes should turn red. You should notice that the value I changes but letter never moves on. It is D all the time, and that is why letter count never gets beyond 0. But why does it never move on? So what's the problem? We have taken 0 1. Okay, we have always taken 0 1, but actually for the first time 0 1 is okay. In the next time 0 1 means 0th index takes single character D. In the next time also we are getting 0 1, but actually it should be 1 1. Index of this one is 1 1. In the next step it should be 2 1. In the next step it should be 3 1, and so on. Therefore the correct one is here you have to put I. Understood? So if you put here I, then you will see. Then now let's run. Now breakpoint is here. That means breakpoint here means once you click the button, this line will be executed, this line will be executed, this line will be executed, then this line will be executed. And since this is a loop, then it for the first time it executes this one, then it comes here and it stops without executing this line of code. Now our program has suspended. Now let's okay, if you run this, our program will stop from here without executing this line of code. Okay, yes, now it has stopped here without executing this line of code. Now we move. Sorry, again I will show you. Then again I will show you. Yes. Now it has stopped here without executing this line of code. Now if you look at the values, I is 0, letter is D. 0 1, when I is 0 0 1, that means D will be taken, letter is D. Okay, now when we click this, it comes here. Then again I increments, condition is true, then it comes here. Then when it is executed, now I is 1, 1 1 will be taken. 1 1 means 0 1. Index of here E character is there. We take one particular character, then E will be taken. Okay, now let's see. Yes, now letter variable stores E, and this condition is false anyway. Then it comes here, again it comes here. Now it comes here. Now I is 2, then it has taken B, condition is false anyway. Now it goes here. Now I became 3. It has taken U, still condition is false. Now I became 4, condition is true. It has taken G, now condition is true. Therefore you can see it came inside the block. okay, and letter count will be incremented. So if you consider this is still 0, now it became 1, again it goes here. Now I value is 5, condition is true. Then the next G will be taken, okay, next G will be taken, then letter count will be incremented by 1. Now it became 2, okay, and now we move here. Here again I became 6, condition is true. Then I was taken, this I was taken, condition is false. Again I became 7, condition is true. Now here N was taken, again it goes here, I became 8, condition is true. This N, now N was G was taken, now here condition is true, therefore we could come inside the block, and after that it moves. Now I will become 9, now I became 9, condition is false, therefore we come to the next, after we exit from the for loop and come to this one, okay, then this line will be executed. Okay, that is how this works, and now I think you could understand properly. Now our program is correct, no? Now when you run this, G appears 3 times. Now our program is correct. So now I have taught you how to use breakpoints, and also how to use locals window to track our logic errors, okay. Exercise: why does letter count never gets beyond 0? Correct the code so that your text box displays the correct answer of 3. When the program is run, think substring string and loops, okay. So anyway, the answer for the exercise is shown here, okay. In this way it has been corrected, okay. Now anyway, now in that way we have discussed how to track errors, okay. Now in the next part we'll take a look at another tool you can add to your debugging armory, try catch statement, okay. Anyway, let's discuss that try catch statements in our next video, and this is the end of this particular video. So you close your work, and okay, and thank you for watching the video.